Hey everybody. Okay, we've got another design here that I finished and flew, and it's a really nice airplane in many respects. It's a typical Mirage-style Delta, but the motor is mid-mount. I wanted to try something that was, able to do really high alpha, high angle of attack with, and you basically need to achieve that with a very low aspect ratio. So the disadvantages of a low aspect ratio is that you don't get extremely good glide for performance. However, that is offset somewhat on this design because of its really good wing loading, really low wing loading. Despite the fact that it's got a lot of wing, its weight is fairly low in comparison to that wing area. And you can do this with a flat plate of foam, but it's kind of like pitchy and not smooth in pitch. So what I did here, and you can probably see, is I actually did make somewhat of an airfoil going on here, using the ping foam starting at 33% of the cord, going to 50% in a second step over there, but then ramping up from the leading edge with a slab of black foam, and then ramping down towards the trailing edge again with a slab of black foam. And of course the ends over here, the trailing edge, is beveled down from starting about an inch towards the rear, towards the elevons. And the same is true for the leading edge. It's beveled down, and you can see that slope right there. It's beveled down going towards the leading edge. I have again a Mirage style vertical fin here, vertical stabilizer, which provides for the yaw stability. The elevons here are quite hefty in order to have sufficient pitch authority. And the side effect of that is, because they are quite hefty, that the pitch authority is sufficient. The side effect is that we get really strong roll rates. So you have to be very gentle on the roll if you want to have just a plain old turn. And I was pleasantly surprised at the way this thing flew. I had one botched launch, and after that, after adjusting trim and so on, that was it. It flew just fine. I was very impressed with the high alpha it could do, although I was a little bit surprised at the amount of power required for a loop. Even though it could, this delta wing design and low aspect ratio typically stall at very high angle of attacks. The amount of power for the loop was quite hefty. I needed, in order to really get the loop to go well, I had to give at least 3/4 throttle, bare minimum. This is a 1000 kV engine with a 9-inch 6-pitch prop that I use for all my planes. I have 3 of these, 3 engines, and I just swap them out of different airplanes. The control actuation is done in the typical fashion with 2 servos that connect to the elevons. The vertical stabilizer has no rudder. I don't really see a need yet for it. I'm going to turn this guy over and show you what I did here on the bottom. One second. Okay, so what we got here is everything's just naked to save weight. Got the engine mid-mount in order to have the ability to have reasonable balancing center of gravity placement, because if the motor was way back there, let's say behind the or in the same location as the elevons, it would be almost impossible to balance this guy with having to move the battery so far forward. It would be way past the nose. As it was, in fact, it was a challenge to get it balanced. I had to put the battery pretty much exactly at, even slightly forward of the nose. Just the battery sticks out to drop past the nose. So now that I'm finished talking about this particular airplane, which happens to look very cool, the fact is that it's a trade-off. And the fact is that the comparison to other airplanes should be made in order to understand what the advantages and disadvantages of each design are. So let's start off with a basic, typical, conventional design. So this one has a zero dihedral wing, so I have the canted winglets to provide some roll stability, which, by the way, this guy has neutral roll stability. You put it into a bank, it doesn't automatically kind of slowly bring itself out of the bank like this one would, because this one has canted winglets. And he's got pretty much no fuselage, this guy. He's got a typical conventional design, rear elevator, horizontal stabilizer and elevator, and vertical stabilizers that are fairly conventional, and just two 3-inch dowels acting as the fuselage here, and then a tractor motor propeller. What is a little bit interesting about this design is that I made the distance between the motor and the elevator minimal, as little as possible, and therefore what was required was a very large elevator for sufficient control authority, pitch authority. This guy flew, I mean, exceptionally well. The funny thing is that sometimes the simplest designs just fly really, really well. And it was just a matter of getting the CG right and trimmed out, and it just, I mean, this guy climbs well, loops well, rolls well. The only disadvantage, and we'll get to that in a second, is that the motor is right up there in the front. And if you crash it, you can have major problems. You know, if you crash nose first, for some reason, you're going to have problems.